So again, it's the same concept applies on this one, is that maybe the original function a of x, maybe that was like root x plus 2, okay? And then b of x is the, and it's kind of go root 5 minus x over x. And really that one could be a composition of other functions too, couldn't it? Yeah. But what we're trying to get, and maybe we do that. Let's do that. Let's say this one here comes as, let's just call it c of x being 5 minus x, and d of x becoming just x. Okay. Oh, sorry. Yeah, x. And we're and then like c divided by d would give me that function there, right? Well, c divided by d, if I take c divided by d of x, okay, it's going to give me, this b of x, this function over here. But in doing that, we want to look at what the domain is. Well, the domain is simply still the intersection of these two things. Okay, when you do division, it's the intersection, except for now we have to also remind ourselves that we got division by 0 in some situations, right? Okay, so the domain of just x, again, is all real numbers. Okay, so that domain, all real numbers. And this domain of 5 minus x, well, 5 minus x has to be greater than or equal to 0, so x has to be less than or equal to 5, right? Okay, so then the domain of c divided by d, okay, if x is all real numbers, then the domain of c divided by d is going to be the intersection of all real numbers along with the intersection of that, which is less than or equal to 5. So then the domain of this function here is less than or equal to 5, right? But what if it, what kind of number is less than or equal to 5? That would provide a problem here. 0, right? Okay, so I need to kick that 0 out as well. Okay, so I'm going to come back and say 0 creates an issue because of that division. Is that all right, everybody? Because remember, we said when we do division, the rule was doing division with functions. It's the new domain is still the intersection of the two original functions that you use to combine. However, you got to do one more step. You have to say the bottom function. And I think in the PowerPoint they call the bottom line g of x. Okay, we're calling it d of x here, but d of x cannot equal 0 because you're doing that division. So we got to kick that 0 out. So right now, by looking at just this, worked well. Just by looking at that right now, we've got the domain to be negative infinity up to 0 union 0 up to 5. That's just that domain. Does that kind of make sense? Okay. Now, we also have to realize that we're looking at that function too. Put it in green. That function too. Okay, because that is this portion, correct? And what kind of numbers does that have to be? We have to say x plus 2 has got to be greater than or equal to 0, right? So then x is greater than or equal to negative 2. All right? So right now, we have that domain and we have that domain, okay? Remembering that this, I know we got just junk everywhere here. Those two things go together, okay? So that stuff there is the domain of that stuff. And the green one is the domain of that one, okay? So if we combine them through addition, their final domain or their new domain is the overlap, right? It's where they intersect. So I'm just going to graph these real quick and think about where they intersect, okay? So we've got negative infinity to 0. So let's go, we got 0, some key points on here, negative 2, and 5. Okay, so every time I start doing the domain stuff and I see, x is less than or equal to this number, or x is equal to this number, those become kind of critical points on my number line, right? Okay, so I put those on. So x is greater, we're going negative infinity to 0. So negative infinity to 0 would look like that. And then 0 to 5 would look like that. Okay? Then in the bottom one, x is greater than negative 2. So we're going those values there. So where do they start overlapping? Negative 2. Okay? And where's the first kind of issue that we start having where they overlap? 0. So we go negative 2 to 0. We'll exclude 0. And then they finish overlapping at 5. And that becomes then the final domain of that problem. Now, that being said, I don't know that every time you see one, I kind of want to explain what we were doing, but every time you see one of these, I'm not saying you have to do that. Okay, you don't have to decompose these functions down into basically the more simple functions that they came from. Okay, but you want to use that approach where we are simply taking we're thinking what are the domain values that I'm allowed to put in here. Okay, so x is greater than or equal to negative 2 there. What are the x values that I'm allowed to put here? Well, the numerator has to be greater than or equal to 0, and the denominator cannot be 0. So what I start doing is I start thinking about all those domains and the restrictions on those domains, and realize that it's a sum of functions. So I got to look at the overlap. I think those are good questions. Does that help? Anything else you guys want to talk about?